So from here we will begin our physics. For that we will require basic mathematical tools, which will be enough for your class 12th and 11th physics. Okay, and we will be only covering the topics which are required or important for our physics concepts only. Okay, so first topic that we are going to take is quadratic equation. Okay, so in quadratic equation you have to understand it is a equation which is of degree, which is of degree 2, means variable, as we know variables x, y, z are there. So if any variables is there in equation that have a highest power, degree means highest power in equation, is going to be 2. Okay, so you should know its general equation. General equation is going to be, okay, x square, because we need a highest power 2 of the variable, so x square we are going to take as variable. X is our variable and 2 is the highest power here. There can be a constant in multiplication here, so a is our constant. Similarly, now other small powers can be also possible, so this is going to be our general equation for the quadratic equation, right? Now if a equation is going to be there for us, we need to find roots for the equation, or sometimes we call it zeros also. Roots or zero is basically means value of x, value of x by which equation gives value 0. Okay, one more word that we are going to use in physics, that is solution. Solution of this equation. So if they're asking you solution of this equation, that will be roots or zeros. Okay, so solution of the equation, if we are going to find, consider in this case we have quadratic equation. So quadratic have degree 2. So if a equation is going to be there, the maximum possible roots is going to be its degree only. So in this case the maximum roots which are possible is 2. Okay, so how to find the roots, that we are going to discuss. How to find roots. Okay, so first case I am going to take here, that is our quadratic formula method. Okay, so quadratic formula requires a equation with us. Consider this equation only, we are taking general equation. So if you want to find the roots here, the value of x which will give the value of this equation to be 0. So x will be your minus b. B is what your coefficient of x, means whatever is there with the x that you have to put here with the minus sign. Plus minus you will put here under root b square minus 4ac divided by 2a. Okay, c here will be the constant which is present in the equation, and a is what your coefficient of x square, right? So plus and minus means what? If you will take plus symbol, that will give you one root. If you will take minus symbol, that will give you second root. Okay, so this is how you are going to find the two roots of a quadratic formula, quadratic equation, right, using the quadratic formula. Second is our factor method. Okay, so for factor method, how we factorize, first we should understand that if equation is there, ax square plus bx plus c are quadratic equation. Okay, so its roots we are assuming to be alpha and beta, like one value of x is alpha, another value of x is beta, for which it will give us the value 0 of the equation. Okay, so these two are going to be our roots here. So if these roots, for them we also can remember two outputs are there. First is our sum of roots will be, means alpha plus beta is going to be equals to minus b by a. Okay, so sum of roots is going to be equals to alpha plus beta, that is equals to minus b by a. Second is our product of roots. Okay, means alpha multiplied with beta, so that is going to be equals to c by a. C is our constant, a is the coefficient of x square. Okay, so now if a equation is present with us, we have to make it in this form: x square plus alpha plus beta into x plus c, not c, alpha beta is equals to 0. We have to convert it in this form. We will understand this by an example. Consider we have equation x square minus 6x plus 9, and that is equals to 0 here. Okay, so first we have to make the roots here. Okay, so 9 should be product of the roots and this should be addition of the roots. So product of the roots, first we have to factorize this. So 3 into 3 is only possible here, or 9 into 1. If we'll add this will give 10. If we'll add this will give us 6. Means this we have to use here 3 and 3. So what this equation we can write as x square minus 3 plus 3 x plus 9 is equals to 0. So this will become our x square minus 3x plus 9 is equals to 0. From this we can take x common. So what will be remaining? X minus 3. And from here we can take minus 3 common, so here also x minus 3 will be remaining. Okay, and from these two terms we have x minus 3 common here, so what will be remaining? X minus 3 is equals to 0. Okay, so from here we will get roots 3 and 3, means equal roots will be there. Okay, now same thing we can use here in the quadratic formula. If the equation is same here, x square minus 6x plus 9 is equals to 0. We can find the roots here also using the quadratic formula. We'll just see how to use it. So minus b square first we have to put here. Minus b square. B is here 6. So not b square, minus b only. So minus of minus 6 plus minus under root b square minus 4ac. So 6 square will be how much? Minus 6 square will be 36. Minus 4. A is our here. What is there in the multiplication with the x square? 1. 1 into c is our 9. And this will be divided by 2 into a. A is again 1 here. Okay. So when we will solve this, minus minus, it will become plus 6 plus minus under root 36 minus 9 times 4, 36. So that will be 0 divided by 2. So here if we'll cancel this, we will get 3. So x is equals to 3 only we are getting here, means the only one root is there, that is x equals to 3. Okay, so this is going to be our quadratic equation. We just need to remember the quadratic formula here, factor method here, and sum of roots and product of roots. That is the only use of quadratic equation in the physics. Okay, so if the equation looks familiar to you, you will use factor method, and if you are not able to directly make the factors of that equation, just leave it and start using the quadratic formula. Don't waste the time on making the factors. Now our second topic will be few identities that we have to remember. few identities only we have to remember here, like you have seen already. A plus b whole square, definitely you should remember, that is a square plus 2ab plus b square. Next will be a minus b whole square, it will be a square minus 2ab plus b square. Next, a plus b whole cube you have to remember, that will become a cube plus b cube plus 3a square b plus 3ab square. Okay, similarly a minus b whole cube also you have to remember, it will be a cube minus b cube minus 3a square b plus 3ab square. Okay, so this you have to remember. Few more are there, that is a square minus b square, important in physics. Okay, maybe you haven't used it much, but now you will be using it. Okay, now few more are there, a cube minus b cube, so that will give you a minus b, a square plus b square minus ab. Okay, a cube plus b cube will be how much? So that will be a plus b, a square plus b square plus ab. Right, so these many identities you should at least remember. Okay, right. Now for power 2, yes, we can expand that. 3 we can expand it if, third thing that you have to remember here, that is your binomial expansion. Okay, suppose we have 1 plus x. I'll use only the things that we will need in physics. Okay, so consider you have 1 plus x power n here. Okay, and we need to find the value here. So how we are going to find it? We are going to expand it. So how to expand if a power is n here? Okay, so for that I am just telling here. So 1 by 0 factorial will come first, plus n x divided by 1 factorial will come here. Then the next term will become n. 1 you have to reduce in n, so that you have to multiply here n minus 1, and you have to increase the power of x by 1, x square divided by 2 factorial. Okay, so here also x power 0 was there, since it is 1, so it became 1 only. Okay, so here if you can see x power 0 was there, then x power 1, x power 2, it will keep on increasing up to we will get x power n. So when x power n will be there, we can see here initially 1 was there, then n into n minus 1. So in the next term it will become n minus 1, n minus 2. Until the last term it will become how much? 1. So that will be basically n factorial. And in the division also n factorial will come. So those will get cancelled. Only the last term that will be remaining will be your x power n only. Okay. So if firstly it is not required for us, if you need to find out how many total number of terms are there in this, so that is going to be n plus 1. Okay, so total number of terms here in this case, when 1 plus x power n we are expanding. So if n is the power here, total number of terms that we are going to get is n plus 1. Okay, so what is the use of this binomial expansion in our physics? That is for approximation. That is for approximation. Why? Because sometimes in physics what we will do, consider a road is there. So if temperature is increased, we know things elongate when temperature increase. So how much elongation will be there? And we also know that elongation is going to be very less if temperature increases there. Okay, so that negligible increase in length, how you are going to find? So that approximation there you need. So that we are discussing here in binomial expansion. Okay, so how we are going to do that? here if you see 1 plus x power n is there. So how to use that approximation here? We have to assume one thing here. If 1 is or x is very less than 1, then we can use this approximation. If 1 is there already, one term. The other term which is present here is x, and I am saying if x is very less than 1, means it is approximately negligible compared to 1. We can take example 0.000003. If you have 1000 rupee and you are giving this much money into that, so how much money now you have total? Approximately 1000 only. This is negligible compared to that 1000. Okay, so that's what we are trying to do here. So x is negligible compared to 1 here. So now if you try to expand it, what we will get? 1 is the first term. Next term will be our nx. Next term is going to be how much? n minus 1 into x square divided by 2 factorial. In the fourth term, what we will get? X cube. Okay, now consider, as we have assumed that x is going to be very less than 1. Okay, so for example, consider we are taking 10 power minus 4 here. 10 power minus 4 means how much? 0.000 and 1 means 4 decimal places it have, right? So that we are taking as an example for x here. Okay, so if we are expanding here, okay, first term we will get as 1 only, plus what we will get? N into 10 power minus 4, right? That is up to 4 decimal places. Consider the next term that we are going to get here. 10 power minus 4 square means 10 power minus 8 we will get. Next term will be even more than that, so that will be 10 power minus 12. Okay, and in physics we don't need answers up to 8 or 12 decimal places. We need maximum up to 3 or 4 decimal places. That is the maximum. Okay, so what we are going to do there, these extra expansion values we are going to neglect those there. So if these values are getting neglected here, what we have only remaining? 1 plus nx. Other things got neglected, means this only we will having there. Okay, so we have to remember here what is useful for us here. 1 plus x power n. If this is the question and one condition is given to you, if x is very less than 1, then this will be approximately becomes how much? 1 plus nx, that we have seen up, right? Now you can remember this also. If 1 minus x power n is there, its approximation will be 1 minus nx. Same way, x replace it with minus x. Okay, if 1 plus x power minus n is there, its approximation will be 1 minus nx only. If 1 minus x power minus n is there, its approximation will be minus will become plus. So these things you have to remember, or at least you have to remember this. Okay, so this should be there with you, right? Okay. For this we can take one example here. Consider we have 0.999. Okay, this is given to us, and its power 3 we have to do here. Its power 3 we have to do here. So if someone is asking you approximate value of this, that will be how much? So first we have to make it in that form here, 1 plus or minus x form, right? So here this will be only minus only because this value is less than 1. So it can become how much? 1 minus 0.001. If we'll reduce 0.001 from 1, that only will give us 0.999. and its whole cube is given to us. So we have to find approximate value of this. So that will become how much? 1 minus nx minus n is our 3 into x is how much? 0.001. So we'll just solve it now. 3.003. Solve it furthermore. So now 1.000 is there. We are reducing 0.03 from that. So it will become how much? 99, like this. Okay. So in physics, if they are trying to ask this kind of question, you have to solve it in this way. You have to give the approximate answer there. Okay. So in this way, you are going to solve there. I'll give few more example on that. Consider 1,000,000. 1 is there. Okay, and its power 4 you have to solve. Right? Its power 4 you have to do. Or we can take an example here, 1 by 4. This you have to solve. Few questions only, you can do it by yourself. Now next is our 1,000,000 or 001 power 1 by 3. Find the value of this also. If you have 1, 2, 3, 4, or 1, 2, 3, 4 and 5, its power 1 by 5 you have to find. Okay, so these three questions try to do by yourself, and this is all about binomial expansion. Where we use it for the approximation only, this part only. After that, our next topic is progression. Okay, so first in this will be our AP. It is arithmetic progressions. Arithmetic progressions. Okay, so what is arithmetic progressions? It is sequence of numbers having constant difference in terms. Okay, if a sequence of number is there, consider 1, 2, 3. Basic example we will take 3, 4, 5. This is a sequence. Okay, so as we are going from 1 to 2, okay, there is a common difference. There is a difference in them, that is 1. If we are going from 2 to 3, there also there is a difference, that is also 1. Here also one difference is there. So they have a common difference here among all the terms here. As we are progressing in the sequence, there is a common difference, and that is 1 here. Okay, we can take one more sequence here, 2, 4, 6, 8, 10. Okay, so if you see here, from the first to the second term we are going, they have common difference of 2. From second to third we are going, if that is, again 2 differences there. This is also having 2 difference, and this is also having 2 difference. So these two are arithmetic progression. Okay, we will take one more example. Consider we have 3, 5, 7, 9, 10. Okay, we need to check if this is arithmetic progression or not. So if this is our arithmetic progression, it should have a common difference among all the terms here. These two terms have how many difference? 2. These two have 2. These two have also 2, but these two have only 1 here. Okay, all these terms had 2 as a common difference, but only here we are able to see difference between these two terms is 1. Okay, so if only one defect is there, then also we will not consider it as a progression or sequence here. Okay, so arithmetic progression we have seen here means if A is the first term in a sequence, A we are giving a name here, first term. Okay, next term will be our A plus some common difference will be there, Okay, so that common difference we are giving it a name of D. So D here is common difference. Okay, so next term if we try to find here, that will be A plus 2 into D, right? Here only D got increased. In the next one more D will get increased, so it will become A plus 2D, right? So same way if it have n terms here. Okay, so if this is our AP here, what are the things that we are going to find? That is nth term. Okay, if you are some way able to locate the AP in the question, then nth term maybe you have to find. So how will you find nth term in that case? So we are going to write it as a nth, means nth term is going to be how much. So for that you have to remember this formula here. A plus n minus 1 into D. So this will be our nth term. Here A is what, your first term in the sequence. What is the first term? N is number of term. Okay, number of term which we are looking for. Consider a sequence is there, in that many numbers are there. So 11th term if you try to find, okay, so that 11 you have to put here. D is, we have already discussed, it is our common difference. Okay, now next thing that we might use in progressions, that is sum of n terms. Okay, example, we had a sequence 2 4 6 8 10, right? So if we want to find the sum of all the terms in the sequence, in this number of terms are 5. Okay, common difference if you are able to see, take any two terms, subtract them, so that will be 2. Okay, difference we are able to find, or we need here first term here is 2. Okay, so if you are able to find, if they are asking you to find sum of all the terms here, means they want you to add all the terms here. So sum of n terms will be how much? Sn equals to, you have to remember this, n by 2, n is our number of terms, we have to divide it by 2, bracket 2a plus n minus 1 into d. Okay, so this we have to remember, or maybe you have to use this also, n by 2 a naught plus a n. This means what? A0 means a naught, means first term, and this is going to be your last term up to which you are looking for the sum. Okay, so this will be your last term here, or nth term you can also say. Okay, so these things you have to remember about the arithmetic progression here. Okay, how to find nth term, how to find sum of n terms. Okay, after that we have here arithmetic progression is done, then we have geometric progression. Geometric progressions, or we can say it as GP also. This is sequence of numbers whose each term is obtained by multiplying its previous number by a constant quantity. Okay, so this is going to be our geometric progressions. Means what? We will take example of this also. Consider 1 is our first term here, okay, and I am multiplying it with 4. So next term that I am getting here is 4. Okay, so here sequence will be what? The previous number. If I tend to find this number here, so this number will be found by the previous number multiplied with the same number that we is getting multiplied here. So here we have multiplied with 4. Now we have to again multiply it with 4 and we will get 16 here. Next term again we have to multiply with 4, we will get 64 here, and so on. Okay, so in this all the terms, consider one more example here. 2 is there, then 4, then 8, then 16. This kind of sequence also is there. So here each term is getting multiplied with the constant number here. Okay, so if 2 and 4 is there, 2 got multiplied with 2, then it became 4. 4 became multiplied with 2, then it became 8, and here 8 multiplied with 2, it became 16. Okay, so this is how the sequence is going to be. Every term, every following term will be a multiple with the constant quantity of a previous number, right? Now we can write the general form of this, general form of GP. So what is going to be that? First term again we are taking it as A. Okay, so next term will be A and multiplied with the constant quantity. We are giving it a name R here. So R is what we call it, common ratio. Okay, a common constant term which is getting multiplied again and again, so we are giving it a name common ratio here. So to find the next term we have AR as the previous term now, and we have to multiply R again here, so it will become R square, and next will be R cube, and it will keep on going like this. Okay, so here also maybe they will ask you to find nth term. Okay, so here how will you find the nth term? That you have to remember from this. So a nth will become how much? A into R power n minus 1. Okay, so this you have to remember in this. Here also you may have to find sum of n terms. Okay, so here also you have to find sum of n terms. If n terms are there, what is going to be the sum there, right? Sum here will be Sn, I am writing as A, which is the first term. It have to be multiplied with R, that is the common ratio here, power n minus 1, and it will be divided by R minus 1. Okay, in few cases you have to find sum of infinite term. Okay, if a sequence is there and it have infinite terms in this, we can take example of that. If 1 is the first term in a sequence, next is 1 by 2, then next will be multiplied with half again, it will be 1 by 4, same way again 1 by 8, and it will keep on going like that, and up to infinity it is going. Okay, so in that case how will you find the sum of infinite terms? Okay, so for that first you should have a condition, R should be less than 1, then only it will be meaningful to find sum of infinite term. Okay, so that will become how much? A, which is the first term, A, which is the first term, divided by 1 minus R. Okay, so this is how you will find the sum of infinite terms. We will complete this example here. So in this sequence, sum of infinite terms will be how much? A divided by 1 minus R. So first we have to find A here. So A will be how much? First term, which is 1. How we will find the common ratio here? What is the common multiplying term here? So for that we will take the any term. Okay, consider A3 we are taking here, third term we are taking here. So we have to divide with the second term. to get the common ratio among them, right? So any term you can take a n, if you are taking, so you have to divide it with the a n minus 1. Okay, if you know the first and second term, then you have to take the second term divided by the first one, right? Okay, so if we are going to find the common ratio here, I'll take the second term and divide it by the first term. So second is our 1 by 2 and we will divide it with 1. So common ratio here will be our 1 by 2 and this is our first term. So sum of infinite terms will be how much? 1 divided by 1 minus r. R is here 1 by 2. So this will become how much? 1 divided by 1 minus 1 by 2, that will give you 1 by 2. So this will be 2, right? So this is how you have to find the sum of infinite terms in geometric progression. Okay, so these four topics you should understand. First was our quadratic equation, second is our identities, third is binomial expansion, and fourth is our progressions. So these basic things that we have discussed, that only you have to remember in this. Okay.